Alright, so welcome to the fifth video. This is the second to last video for our chapter on roots. This video is for equations involving radicals. So you can see up here we have an equation involving a radical, and let's just say what the most important thing involving with any equation. The main goal in any single variable equation is to isolate the variable. And so, if I give you a couple of examples, things like 2x minus 4 equals 8, there is a single variable equation. X squared minus 2 equals 2, right? There's another single variable equation. And now that we have square roots, we're going to have more single variable equations. Radical 2x equals 3. Things like that. And so every time you see an equation, and remember what makes an equation is an equal sign. Right? Whenever you're given something like this, the first thing that should pop in your head is, as long as there's only one variable to begin with, like x, I need to solve for x. So the way to get x by itself is to look at all of the things which are being done to x and just start undoing them, but you undo them in, if we do things to x in PEMDAS order, we need to undo them in reverse PEMDAS order. Remember that PEMDAS is parentheses exponents multiply and divide and then add and subtract. Right, so normally when you are evaluating something, we go in that order, but we are going to go ahead and undo things in that order. And we always go furthest away from x when we do this. So let's look at an example not involving radicals. So we're trying to solve 3x minus 2 equals 7. And remember, you want to get x by itself. And so what we have to do is we have to get rid of the furthest away stuff from x one by one. And so right now the furthest away thing from x is this subtracting 2. Right? This is the furthest away. And so the way we can get rid of subtracting 2 is by adding 2 to both sides. And that gives us the equation 3x equals 9. Now, there's only one more thing that's happening to x, and that's multiplying by 3. And so now we need to divide both sides by 3. And when we clean up, the 3's cancel. 3 goes into 9 3 times, and we get x equals 3. So this is how we can solve equations involving radicals too. So our first example is just going to be the square root of x equals 3. And so the square root is the only thing happening to x. Right? So here the square is the only thing happening to x. So the opposite, right? The opposite of square root is squaring. Right? See what we did over here. To undo subtracting 2, we had to add 2. To undo multiplying by 3, we had to divide by 3. And so to undo taking the square root, what we need to do is square both sides. And so, again, we'll take rad x equals 3, square both sides, and what we get is x equals 3 squared is 9, and there's our answer. Let's try another one. The square root of x equals 5. Again, square both sides, and you get x equals 25. So what happens if it's more complicated, like the square root of x minus 1 equals 3? How do we know the correct order to do things? Well, here, look at your x, and look at the thing happening closest to x. This is the first thing we do to x. This is the last. And remember, we're going to go last in, first out. And so what you need to undo first is this minus 1. So if we have rad x minus 1 equals 3, first we have to add 1 to both sides. Now the 1 and the negative 1 cancel, and we're left with rad x equals 4. Now we can square both sides, and we're left with x equals 16. How about 2 radical x equals 6? So look at the x, here's the x, and look at the thing closest to x. The first thing that happens to x is the square root, right? So the square root is number 1, and then multiplying by 2 is the second thing. So this multiplying by 2 is the last thing to happen, so it's the first thing we got to get rid of. So first we're going to divide both sides by 2, and we get radical x equals 3, and then square both sides and get x equals 9. So let's go for broke and try to solve this. Let's try to identify the order things are happening to x. So look at x and look at the thing that you would do first. The first thing you would do is add 1. The second thing you would do is take the square root. The third is multiply by the 2. And the fourth is subtracting 1. And so what we're going to do is we're going to undo those things in backwards order. The first thing we have to do is get rid of subtracting 1. So we take our 2 radical x minus 1, x plus 1 minus 1 equals 3, and add 1 to both sides. We get 2 radical x plus 1 equals 4. Now look back. We've just crossed number 4 off our list, so now we got to do number 3, multiplying by 2. The opposite of that is dividing by 2. We get the square root of x plus 1 equals 2. Now cross off number 2. 2 is the square root, so square both sides, and you get x plus 1 equals 4. And now cross off number 1. The opposite of adding 1 is subtracting 1. And that gives us that x equals 3. We can go back and we can check in our original equation. 2 radical 3 plus 1, right, there's our x, minus 1 is 2 times 3 plus 1 is 4, so 2 radical 4 minus 1, which is 2 times radical 4 is 2, minus 1, which is 4 minus 1, which is 3. And so it checked. Let's try radical 2x minus 1 equals 3. So again, we square both sides because, well, let's look at the order of things happening to x. The closest thing to the x is multiplying by 2. After that, we subtract the 1, and then we take the square root. So we need to undo the square root first. And so we get 2x minus 1 equals 9. We now need to undo subtracting 1. And so we get 2x equals 10. And so x equals 5. Now what happens if you have variables on both sides? Suppose we have the square root of x equals x. Well, we have to make a choice, but the order is this. 1, get the root by itself. So step 1 is to get the root on one side by itself. So here we've already done step 1. Step 1, the root is all the way by itself on one side. 2, square both sides. So step 2 says take radical x, square it, take x, square it, and then what we're going to get is that x equals x squared. 3, you need to determine which technique will isolate x. Here, I have an x squared, so remember, whenever you have a highest power of x squared, we need to move everything to the same side. So I can subtract x from both sides, and I get 0 equals x squared minus x, and then I can factor. There's a common factor of x, and so I get 0 equals x times x minus 1. And because we're multiplying two things and getting 0, we can set both of them equal to 0, and I get x equals 0, and I get x equals 1. And then when you're done, whenever you have a square root, you should check all answers. And I can't tell you this enough. Check every answer every time. Let's look at radical x equals x, and check x equals 0. The square root of x equals x becomes the square root of 0 equals 0, and that's true, right, because 0 times 0 equals 0. Now check x equals 1. Radical x equals x becomes radical 1 equals 1, and that's also true. The square root of 1 is 1. And so we found the two answers, both worked. So you may be wondering why we have to check our answers, and I'll go ahead and give you the reason why. So remember, step 1 is get root on one side. Step 1 is done for us. Step 2 is square. And so we're going to square both sides. When you square the left side, all you get is x plus 1. However, when you square the right side, it's really x minus 1 times x minus 1, and if you FOIL, you get x squared minus 2x plus 1. And so here's our new equation. Because we have an x squared, we're going to have to move everything to the same side, and then we're going to factor. And so to do that, we need to subtract x and subtract 1. So we're going to subtract x and subtract 1. And so let's go ahead and finish that. These cancel, and I'm left with 0 over here. And so what I get is 0 equals x squared, negative 2x minus x is negative 3x, and 1 minus 1 is 0. Now, an x factors out, leaving me with x times x minus 3. And so we get x equals 0, and we get x equals 3 as our answers. So let's check. The square root of 0 plus 1, does that equal 0 minus 1 squared? Well, that's radical 1 equals negative 1 squared equals 1. That's true. The square root of 3 plus 1, does that equal 3 minus 1 squared? My apologies, sorry. This one worked. Let's go back to the original equation. The original equation, ignore what I just said. The original equation was radical x plus 1 equals x minus 1. So we need to check x equals 0 and x equals 3. So I'm going to start with x equals 3. Radical 3 plus 1, does that equal 3 minus 1? Well, this side is the square root of 4, and we want to know, does that equal 2? That is true. So 3 works. Here, we have the square root of 0 plus 1, and we want to know, does that equal 0 minus 1? So is the square root of 1 equal to negative 1? Well, that's not true. Remember that any time we have the square root symbol, we always take the positive root. And so that's not true. And so here, the original equation, before we squared both sides, was just the radical x plus 1 equals x minus 1. We got 2 answers, only one of which worked. We have to reject this one by checking. So that's really it. Here are the things that you have to remember. The way you undo the square root is by squaring. And so if you have an equation with a square root, you must square both sides to get rid of the square root. Once you square both sides, you can then solve. But sometimes, like in this case, you have to move a bunch of things away before you can square. So always remember, get the square root totally by itself, then square both sides. Sometimes this will involve having quadratic equations, so we have to remember how to factor. And then at the end of the day, you must check your answers. And that's it. So go ahead, do the homework, and I will see you in class.